All right, today we're going to start our last chapter of new material. We have a couple things to do after that with some manipulatives, but this is our last book material we're going to do, is chapter 10. This chapter is all about graphics and statistics. So representing material in a way that people can understand in a statistical nature, which includes graphs. And we're going to start, the first two sections are about displaying data with graphs. So to start with, we're going to talk about a pictograph. A pictograph is maybe one of the most basic types of displays of data. You see it used with really little kids. And what they do is they use pictures to represent tallies within categories. So I've got an example for you. It's maybe not the kind of example you would use with the little children because it's a little bit morbid, but it gives you an idea of how pictographs are even used at a larger level. An Automobile Club of America considers holiday weekends to start on Friday at 6 p.m. and last until Monday at 6 p.m. If 150 people died on such a weekend by 6 p.m. on Saturday, 80 people died from 6 p.m. Saturday to 6 p.m. Sunday, and 100 people from 6 p.m. Sunday to 6 p.m. Monday. Draw a pictograph of the data. So you're probably not going to use this in kindergarten. It's a little bit sad. It's just a little bit sad. But the content and how we're using it, you certainly could. So a couple of things about graphs in general. Graphs need to have titles. All right, so whatever graph we create, no matter what it looks like, it's going to have a title that sort of describes what's going on. It also usually, if there's any kind of symbols, needs some kind of a legend or a key that tells what the symbols mean. With pictographs, you want to be a little bit careful that whatever symbols you use, if you needed to use sort of like half of that symbol, it would make sense to draw half of that symbol and be discernible from other features. So for example, you might want to let one box represent something, but sort of drawing a half of a box, if you're not careful, can look like you've just sloppily drawn a whole box. So, so think about your pictures that you're using in a pictograph so that they're easy to cut in half. So what does that mean? So maybe you use a circle. I think half of a circle is pretty discernible from a whole circle. The one I'm going to use on this one's a heart. I can definitely discern half of a heart from a whole heart. And I mean like, you know, the image heart, not the heart inside your chest, that one. So those kinds of images are pretty good. If you decide that you wanted to use a box, that's okay. But if you think real critically, you know, if your box looks like this and you wanted to draw half a box, it would be better to draw half a box like that as a triangle than half a box as sort of a skinny rectangle, because a skinny rectangle looks an awful lot just like a sloppy square, okay? So be thinking critically about how you draw it so that it's clear what you're trying to say. So here's what we're going to do. We're going to draw lines, 4 lines, in fact, just across the screen. And they're just going to separate the days of the week that this is referencing, okay? You don't have to draw them 4 lines. I just think it makes it easier to keep all of the data sort of neat. And each of the data is going to describe the different days of the week that this is talking about. So on the first one, it says Friday at 6 until Saturday at 6. So I'm just going to call that Friday. If you want to be more descriptive, that's fine. But this is Friday. Okay. It's not very good pinpoint. Try that. Friday, and then we have Saturday. And then we have Sunday. So I'm just indicating what day it starts on that we're making our calculation. Now, if you take a look at the numbers that it talks about, how many people? There's 150 people, 80 people, and 100 people. And no matter what we choose to do, we're probably not going to want to draw 100 images, right? That's not going to be very helpful. So we need to let our image, whatever we choose, look like it's representing more than one person's death. So we could divide by 2 pretty nicely, but still I don't want to draw that many images. So what are some options of things that you might want to divide all these numbers by that would be easier to do the drawings? 10 might be good. So if I did 10, I'm going to have to draw 15, 8, and 10. That's not bad. If you wanted, I'm going to do one just a little bit more abbreviated from that just to show you what it would look like. You could divide by 20. I just want to show you what happens when you have half of something, okay? So I'm going to choose on this one, and you can do it differently if you want to choose the 10, that's totally fine, to draw that my heart is going to represent 20 people's deaths. So one heart represents 20 people. So if I use that, how many hearts would I need for 150? How many? 7.5, exactly. So I'm going to draw 7 hearts. I need my hearts to look like they're about the same size, spaced about equally apart. And of course, that's not going to be perfect, and that's okay. And then in drawing half the heart, there's my half. So that's how you would do it if you ended up with this. If you did it for 10, you're just going to draw 15 hearts or 15 circles or 15 whatever image you chose. How many am I going to need for Saturday? Not for Friday, for Saturday. 4. Saturday is the 80 number, yeah. So we need 4 of them. One of the things to be really careful of is that you don't inadvertently cause someone to think something's going on that's not. In this regard, what I'm talking about right now is making sure that as I draw my 4 hearts, they're lining up with the first 4 hearts of the first row. If I were to draw the hearts significantly larger or smaller so that they take up more room or less room than the first 4 hearts of the first row, it leads you to sort of an inappropriate conclusion. So I'm going to draw and make sure that at least my 4 hearts are in the same 4 kind of columns as the first ones. See how they're lining up? And then on the last row, how many hearts am I going to have? 5. And again, they should line up with the hearts from the first 2 rows. So there's my 4, and then here's 5. So some of the nice things about the pictograph, I haven't written my title yet, and I will, but some of the nice things about the pictograph is that I should be able to look at it sort of at a glance, and I should be able to say a lot of things like, oh, look, there was a lot more between Friday and Saturday than there were between Saturday and Sunday or Sunday and Monday. I should just be able to see that. I don't even have to count to know that, right? Because I see it's way longer. You could even look at that and probably say, look, I mean, like Friday's almost twice as many as Saturday. Yeah? You can also look and you can say, hey, look, there were deaths on every single day. It wasn't like it just all bunched up in one place and there's nothing somewhere else. Okay, so one other thing to do then is a title. And I don't care where the title is, so the title can go above it, the title can go below it, depends on what kind of resources and things you're looking at. Because I've got more space on mine right now, I'm going to put the title above it. But what is this a pictograph of? But deaths, how? Okay, so deaths, how would I'm going to start first say on a holiday weekend. And then you mentioned by automobile accidents, which is also pretty specific, right? Because there could be other accidents taking place that are not represented in here, or deaths taking place that are not represented in here. And we want to be sure that we understand that's the difference. Okay, everybody good? So, gotta have a key or a legend. That's where my heart equals the 20 deaths. Gotta have a title. All right, let's take a look at another type of graph. Another type of graph is called a dot plot or a line plot. Depends on the resources you use. This is a fairly quick way to display data with fewer than 50 values. So we do not want something that's got 125 values. It won't be useful to use this. It becomes cumbersome. Okay, so the example that I'm going to use talks about weights of children, mass actually. So this is the mass in kilograms of each child in Mrs. Good's class. We have lots of numbers here, but we don't have more than 50, right? And we're going to make a dot plot for the data. Okay, so just like before, we need to make sure we have a title. We don't really need a key necessarily on this because of the way the graph goes. But let's actually just do our title first so that we remember to do it this time. Whatever we're about to create, because I haven't created it for you yet, so you know what it looks like, it's going to represent what is described in our data or our paragraph above. So what is this graph going to represent? So the mass in kilograms of children in Mrs. Good's class, right? This is not real data from a classroom, but Mrs. Good was one of my children's teachers. Isn't that a great name? Mrs. Good. Okay, you're going to draw a line. And you need to mark each of the values that are represented in the data set. So we need to start at what? What's my smallest kilogram value? 39. And what is the largest one? What is it? It is 49. So I'm going to start at 39 and make a hash mark for every number and stop at 49. And they should be equally distributed, right? So they should look approximately even across. Like your graph can't bunch all the numbers together and make a big old jump, you know, and then skip some space and then call it the next number. So they need to look equally distributed. There's 39, 40, 41, 2, 3, 44, 45, 46, 47, 48, and 49. Okay, perfect, no, fairly even, yeah, pretty good. And what we're going to do is we're going to go through our data values one at a time, and we're going to make either a dot or an X. I choose to make X's because I think it's easier to keep them sort of organized in a way that looks reasonable and doesn't start looking a little bit wonky. So here's what that would look like. So the number 40 would put an X above the 40, hash mark. And I'm just going to mark them off as I go. 42 is next. So the X in the 42 column needs to be about the same size and at about the same height as the X in the 40 column. And then I have 49 and 41. So I've got 49 and 41. Then I have 43 and 42. So here's 43. And then when I get to 42, I have to stack it. Okay, so two X's. 48, 39. So 48, 39. 46, 41. 42 and 40. Stack again and again. 49, 45. 39, 43. 47, 44. 49, 42. And again, at a glance, you can kind of see that most of the kids are bunching up in here between the 39 and the 43, right? There are a few, and then they've got a couple of kids at the end that are, balancing out this sort of heavy end of the spectrum. But you can see at a glance kind of how the weight or the mass is distributed among these children. I'd like to show you what happens if you inadvertently make a mistake in how you're drawing this, or if you're not thinking wisely. If you were to draw some of these in such a way that they were larger than others, can you see how you would be misinformed by glancing at it, right? Like there's nothing wrong in the sense of the data being in there wrong, but because of the way it's viewed, right, the way our eyes see that, we would be misled as to what's really happening. And that's actually the reason why we want to make sure that our data all looks uniform, okay? All right, let's take a look at another one. Stem and leaf plots. These are one of my favorites. These are akin, that means similar to, a dot plot. They're drawn vertically, okay? What we just did was drawn horizontally. The numbers on the left are called stems, and the numbers on the right are called leaves. Okay? So, here's a data set of grades. This actually was a real data set of the first exam grades of a we used to call this class Math 2, a Math 2 class from the very first time I taught it, which is like, I don't know, 6 years ago now or something like that. These were the first exam scores that they had. They didn't have redos. None of that happened then. And the way stem and leaf plots work is you make a vertical bar, and this is just a separation bar, okay? And on the left-hand side, you put the numbers in order, and it really doesn't matter if they're smallest to largest or largest to smallest. You just choose. We'll go with smallest to largest because that's what's in my notes. What is the smallest number in this data set? 43. And the largest? 90 what? 94? Okay. So that tells me that I'm going to need a 40s row, a 50s row, a 60s row, a 70s row, an 80s row, and a 90s row. Everybody good so far? So the left-hand side of this chart is representing the tens digit in a grade. So far, so good? The right-hand side is going to represent the units digits. So when I go through this, I'm going to do this twice so you can see how it ends up looking at the end, because I need an intermediate step at the beginning. Sorry, I'm trying to do something. I think my stylus is on its last leg. All right, so 87 means that on the 80s row, I'm going to put a 7. 76 means on the 70s row, I'm going to put a 6. 94 and 58, so 94, 58. 82, 43, 82, 43. 89, 53. 89, 53. And we're going to fill in all of those details. So I'm going to stop talking and let you fill yours in, and then you can just visually check to make sure they match mine when you're done.
Do we put 7 twice?
Yes. If a number occurs twice, you're going to write it there twice. I think I got all mine on. Okay. Now if we leave it this way, at the very least we can kind of see sort of like grades, right? I can look at here and say, oh look, there's quite a few B's, same number of A's and C's, and then I've got some other sort of smaller numbers here. And that's useful. I mean, there's nothing wrong with that. It's not complete though. Completing this particular table, which you can do from the get-go if you're very careful and meticulous. I'm not usually. I create this one first always. We're going to recreate this where we're going to put each of the rows themselves in order. So I'm going to have my same bar that I had before, my same 4 through 9 that I had before. And so the first row is no big deal because there's only one thing on it, 43. But the next one would be 53 and then 58. 67, and then I have 2 4s, a 6, and a 7. So again, 4, 4, 6, 7. 0, 2, 7, 7, 9, 9. And 0, 0, 4, 4. So using this part of the stem and leaf plot, you can actually see all the grades in order from smallest to greatest, right? Notice a couple of things that I did as I was working. All my columns line up, right? None of the numbers are bigger than any other number. They are on top of one another, you know, vertically speaking. So again, I can look at this and see that the 8 has more numbers in it, but if I had been not careful and written my numbers in the 8 rows smaller, I might not necessarily be able to see that as easily, that kind of stuff. There are 2 things I need to write down for this table. I need to write down a title. I'm going to make my table just a little bit smaller so I have some space. And I need to write down a key. So here's what this looks like, or a description at least in the title so that I know what's going on. So I'll write mine as a title and a key. So these are grades, right? Grades from a first exam. And somewhere on here, the key, or top and bottom or whatever, I'll do it on bottom this time, needs to say what this means. So you can pick any of the numbers on here, it doesn't matter. I'll use the one on the bottom row. 9/0 is a grade of 90. Does that make sense? Simply that very simple statement, 9/0 gives a grade of 90, tells you what the rest of all of the data means. The number on the left is the 10 stitches, the number on the right are the 1 stitches, and I can see them at a glance. So this is a stem and leaf plot. You can also use stem and leaf plots to compare data. Those are called back-to-back stem and leaf plots. So these are two stem and leaf plots combined for comparison. One of them will have the leaves to the right, just like what we just did, and the other one will have the leaves to the left. Okay, so now in order to actually do the back-to-back stem and leaf plot, I need to have two stem and leaf plots, and I already created one. I haven't actually created the other one. This is actually the same class's second exams of that year, okay? So what I'd like to do first is I would like for us to create the stem and leaf plot that represents this data. If you're careful, you can create the stem and leaf plot only one time with the disorganized approach, like the one that I did on the left over here. And then we can reorganize it and put it into the second, into the form that's organized while we create the other half of my graph, okay? So that's gonna be our goal, to just sort of cut a few things out. So looking at this data, what is our smallest data value on this one? 64. And our largest? 99. So this one only needs from 6 to 9 as stems. So I'm going to write my small stem and leaf plot over here on the left and try to make it smaller even in a minute. But I'm going to have 6, 7, 8, and 9. And again, I'm going to put the disorganized. I don't care where they go, in terms of ordered, just in terms of row. And I'm going to put them in order. So 93, 96. So I've got a 3 and a 6. 98, 66. 67 and 82. Okay, I'm going to fill the rest of mine in. You fill yours in, and we'll check to make sure that they look similar when we're done. As you complete it, just make sure that your unorganized chart matches mine that's unorganized. You have the same pieces all in there. Any questions so far? Okay, so I'm going to draw a large stem and leaf plot over here with those same numbers, 6 through 9 in there, but I'm eventually going to have to include these numbers as well. I'll show you how, but they include 4 through 9. So as I create this, I know I need to have something that includes all the numbers in the stems. So I'm going to use 4, 5, 6, 7, 8, and 9. And I realized for the data set that I just currently have been given, I don't have a 4 and a 5, and that's okay. We'll just ignore them. So starting on the row with 6, if I put them in order, what will I have? 4, 6, 7. How about the row with 7, the 7 row? 2, 4. The 8 row? And notice I'm still lining up the data in columns so that they can be compared easily later. And then the last column, the 90s column. Lots of A's in that particular test. What did we get?
2, 3, 4, 5, 5, 6, 6, 8, 9.
All right, I'm out of space. I'm going to move mine over just a little bit. Okay, trying not to make my numbers smaller, even though I'm running out of space. Okay, what I think I'm going to do, I'm actually going to shift this to a different spot. I don't need it anymore, so I'm just moving it out of the way. Okay, so here's what it looks like to create this so that it includes the other data. I'm going to do another vertical bar on the other side of the 4 through 9. And I'm going to take the data that I created over here and I'm going to put it in backwards order. So I'm going to extend it to the left now instead of extending it to the right. So the number 3 is the only thing in the 4 column, or the 4 row, so it's going to go here. And then there was a 3 and an 8. So it goes outwards from here like this, 3, 8. Okay, so the smallest thing is by the stem. As you move further away from the stem, the numbers get bigger. The next one had a 7 in it. It was 67. And then I have 4, 4, 6, 7. So I'm going to do 4, 4, 6, and 7 as I move out from the 7, away from the 7. On the 80 row, or the 8th row, I have 0, 2, 7, 7, 8, and 9. And on the 90s row, I have 0, 0, 4, 4. So we said that the whole purpose of this particular data set was comparison of data, right? So if you look at the left versus looking at the right, you can see how the data is bunching up differently, right? Lots of B's on the first test, lots of A's on the second test. We've got some lower grades on the first test though too, right? You get those 40s, 50s. Man, I mean, but on the second test, may not have as low a grades, but there's 360s on the second test. I mean, that's not fabulous, right? I mean, it's not like I ended up with everybody actually passing. Overall, though, the grades on the second test were better than the grades on the first test. So you can make sort of a lot of generalizations from looking at this by this type of a comparison. I still need to have the same kind of title that I had on the last one and a specification that shows what this means. So as I'm looking at this, these are the first and second exam comparisons. And I'll put it into the title this time, which is fine, where 8/0 equals a score of 80. And yes, I do realize that on the left-hand side that the order is reversed of that. We're not going to worry too much about that. If you're working with a stem and leaf plot, we need one piece of information for this, the key. All right, let's take a look at another one. A grouped frequency table. A grouped frequency table shows how many times data occurs within a range or class, or a range of classes or intervals. So let's just say that we had the same data as we had before. We're about to do that here in a second. And instead of being very super concerned with the numbers scored, the actual numerical values, I'm really only concerned with the letter grade. How many A's, how many B's, and so forth. That's the kind of data that you can group together. You lose some accuracy, right? Like I lose the ability to know what kind of A's are we talking about. Are we talking about 90s or are we talking about 98s? I lose some ability to actually see information. But it groups it in a way that allows me to see sort of a big picture instead of small details. So in this one, I'm using the same data that I had, I think, on the last data set. Yeah, the last data set, that second exam score. So it says, using the data from the second exam and the standard grading scale, make a grouped frequency table showing the letter grade disbursement for the grades on the test. So what does this look like? Well, we're going to have to make a column that tells what the grades are. So we've got their grades. And it said the standard grade disbursement, so we're looking at 60 to 69, 70 to 79, 80 to 89, And it's really supposed to be equal width, so 90 to 99. If we had a 100, we would put it there and we call it 99 to 100, 90 to 100. But when we're really supposed to be doing this, we're supposed to be making our class widths equal, so that they're all exactly the same width. These widths are actually all 10 apart. Because I start at 60 and I go all the way to 69, that's 10 numbers. Does that make sense for everybody? Okay. And then what you would do, I mean, we already have seen how to do this because we saw the other chart, but what we would do if we were doing this from scratch is we'd make a tally mark. So every time I see a value, I put a tally mark in the right row. So 93, 96, that's 2 tally marks in the 90 row. 98, 66, so I need a tally mark in the 90 row and tally mark in the 60 row. 67 and 82, so 67, 82. And I keep making tally marks in the appropriate row that goes with that information. So I'll do mine, you do yours. It would look like that when I'm done. We have a tally mark column. And then our last column is actually called the frequency column. And all that the frequency column is the numerical digit that represents how many tally marks you have. So this is 3, 2, 4, 9. Yes, ma'am.
When do, I know you wouldn't be doing this like, maybe at higher grades, but when do they teach kids to tally? Like what grade is that?
I don't know. I'm really not sure on that one. I know I've seen it come home in my 4th graders' stuff, but I don't know if it's this year or last year. So probably looking at the upper elementary school would be my guess. But I don't know for 100% sure, Danielle. I'm sorry. Yeah. That's a good question, though. But making tally marks with statistical data, I know we think about statistics being hard, but tallies are not hard. Grouping data is not hard. We can get harder really quickly, and we will. But this would still be at that upper elementary, I believe, 3rd, 4th grade area. All right, we are almost done with this particular chart. We just need a title. So what is the title for this going to be? What would you write?
Standard grading scale for second exam.
Yeah, you can write that. Sounds good. Standard grading scale for, I'll just say exam 2 to cut the words down a little bit for me. You don't necessarily even have to say the standard grading scale part. I mean, it is true, but you could just say that these are the grades from exam 2. That would be sufficient as well. Okay. All right, now there are 2 types of graphs that often get confused. We're about to hit one of them. The 2 types are called a histogram, that's the one we're about to do, and a bar chart. So they both have bars, which is why that can be a little confusing. But let me talk about the histogram first. A histogram is made up of adjoining rectangles. Adjoining, that's a key phrase here on this one. The categories are shown along the horizontal axis and the frequency along the vertical axis. Could those be different? Could we switch to horizontal and vertical? Yes, you will sometimes see that. It's not quite the standard way of doing it, but you will see that represented in newspapers or magazines or something like that, and it certainly would still be could be a histogram and have that feature. Okay, our data keeps staying the same because if I leave our data the same, we don't have to redo a lot of the processes just to learn a different kind of graph, okay? Same data, but we're going to create a histogram. Now, it's going to be easier for us to create this histogram because we already created the grouped frequency chart. So we're really going to rely on the grouped frequency chart more than the data specifically because it's easier to work with since we already did the work. Okay with everybody? All right, so here's the way our histogram starts out. There is a horizontal and a vertical axis. Don't really call them X and Y at this point, but they are horizontal and vertical axis. We have a score from 60 to 69, but we're going to write down 60 to 70, sort of the low end of each of my categories, 70 to 80, 80 to 90, and 90 to 100. Notice the width of each of my intervals is about the same. That's really important, right? Making those widths approximately equal. Now, when I create a chart like this, I need to label what each axis is as well. I didn't give myself space to do that, so let me try that again. My goodness. All right. So what are the 60, 70, 80, 90, and 100? What are those? They're what? They're the grades. Or you could say even the scores on the tests, right? So these are the grades on exam 2. And then on the left-hand column, this is the frequency, or the left-hand, not left. The vertical axis, this is the frequency. So taking a look back at my grouped frequency, how big of a frequency am I eventually going to need? 9. So I need hash marks that go from 1 up to 9, again, approximately evenly distributed. And mine are not going to work. I made them too far apart. I'm running out of space. Let me try again. If you were dealing with data that had much more frequency, like you had things that went to maybe like 50 and 55 and 70, and you could do your hash marks that they represented increments of a different value, like increments of 5. So the first hash mark is 5, and then 10, and then 15, and 20, or 2, 4, 6, 8, something like that, whatever works for your data. You do need to label some of these hash marks so that we have some sense of how far apart these are in terms of their value. So like for me, these numbers are every unit, so I'm just going to label the even ones so that I am not running out of space on the left, because otherwise cramming it in there is going to make it look really hard to read. So I'm just labeling the even ones, and they still have the same full effect as if I labeled them all, right? Yeah. So what are these numbers on the left again? They're the frequency. So we're going to write that down, frequency. And what we're going to do is we're going to make a bar extending from the horizontal axis up to whatever height is represented by the number and the frequency. So in the first one, the 60s row, I actually have 3 exams in that category, right? So I need to make a bar of height 3. Something like that. If you wish, you can make your bars filled in even, right? So I could do this. That's not so good, but you have the right idea. Let's see if I can get my other one back. Nope, I can't. Okay, how about the 70s? How many of those did I have? 2. So I need a bar of height 2. So about like that. How about the 80s? 4. So we need a bar of height 4. And the 90s. 9. If you have and or want to use, you're welcome to use graphing paper for these, if that helps you to feel like you can keep things organized a little bit better. If you don't have graphing paper and you want to use some but you don't want to buy some, you can print it from online too. Just do a Google search for images of graphing paper and there will be lots of different ones showing up. I need one more thing. What am I missing? A title. I need a title. So what's the title of this guy going to be? Yeah. Grades from a second exam. Good job, guys. Now we're going to talk about the differences when we actually create a bar chart or a bar graph. A bar graph is much like a histogram, but there are spaces between the bars to depict categorical data. So we're using it in a little bit of a contrived way here because the data from our second exam business can be thought of as individual numerical values. That's my histogram approach. Or categories of grades, A, B, C, D, and that's the bar graph approach. There are some data that have to be done as bar graphs. For example, if you were looking at data where you were trying to show the differences in something, some kind of characteristic of males versus females. I can't take males versus females and somehow put numerical data to it and put it next to each other and make that make sense. Those are just separate categories, right? So what we're doing right now feels a little bit contrived in terms of the categories because we've created them. But there are some data that are just naturally categories, okay? So like if you looked at data between, just trying to think of things that you can't blend over, like where you live, right? People who live in Oklahoma versus people who live in Alaska. You can't do that. You can't be a both, right? And there's no way to sort of separate it except for category approaches, which would be a bar graph kind of information. So here's what this does. We have the same data that we had before. Our bar graph is going to look a lot like the histogram, but there's going to be separations between the columns instead of them being juxtaposed, adjoining, side by side. We're not going to have that. Everything else is going to feel very much the same. So again, create the horizontal and vertical axis. They're going to be labeled exactly like they were before in terms of the labeling, like the words. This is going to be frequency. And it's going to go from 1 to 9. And these are going to be grades down here, but it's going to look different. So hold tight before you start marking things off. So you're going to draw a beginning and an ending bar, and you can do it either with the low grades or the high grades. I'm going to go with low just so it matches what I did before. This is the D grades, and you're going to leave a little bit of space, and then you're going to do a column for the C grades, leave a little space, B grades, leave a little space, and A grades. And I'm going to have the same heights that I had before, which was 3, 2, 4, and 9. Whoops. And my title is the same too. If you want to be more specific on the bottom, instead of just saying grades on a second exam, you could put the word letter in front of it. These are the letter grades on a second exam. That'd be fine. Okay, we're going to do one more today. The one more that we're going to do is a double bar graph. So we already learned what a bar graph is. A double bar graph is going to be kind of like our back-to-back stem and leaf plot, a way of making comparisons. So our bars representing sort of like the A's, the B's, the C's, they are actually grouped side by side. Okay? Now it's a little bit tricky with this particular data because it doesn't group very nicely because I have, you know, the D's, C's, B's, and A's, and those are all 10 spaces apart, but F's is a much wider range of values. But when we think of it in terms of letter grades, it doesn't matter if you made an F that's a 5% in the class or an F that's a 55% in the class, you still got an F. Does everybody make sense of that, right? So we're not looking this in terms of width being representative, actually, you know, like how many possible outcomes could there be in this category. We don't think of it like that. We're thinking of it in terms of letter grades. So go ahead and create. Again, this is our second information that we had from before using the stem and leaf plot that we're going to do from before. And it's going to have the same frequency on the left, grades on the bottom, all of that's the same, so I'm going to fill those details in as I had before. So here's frequency, and here's, I'll put letter grades. And I'm going to have an F column now because there were Fs on exam 1 for the other test. But there is exam 1 and there's exam 2, and so there's 2 columns that are going to be beside each other that represent the F's, and then I'm going to space it out a little bit. And then there's going to be 2 columns that represent the letter D. And then I'm going to space it out. And then there's going to be 2, bars representing the letter grade of C. And then space it out. And 2 bars represent a letter grade of B. And then space it out. And then 2 bars represent a letter grade of A. And let's fill in the same heights that we just did before. The second exam will occur as the second box in each of these columns. So there were no F's, but there were, no, I don't have my frequency numbers marked in here yet. How many do I need to go up to on, I still only need to go up to 9, don't I? 2, 3, 4, 5, 6. Okay, so there were 3 D's on the second exam. There were 2 C's. There were 4, put in the wrong space, 2 C's, whoops. There were 4 B's. Mine is getting really kind of wide, so please forgive me if they're not quite at the right height. And then there were 9 A's. I think it's about right. And it would be a good idea if you're working on paper, because we're going to actually have to sort of differentiate these in a minute. If you shade these one direction or with one color, and then when I do my other one here in a minute, I'm going to shade them a different way or with a different color. So these are all of my second exams. And in my key, in a minute here, I'm going to actually write that down. So I'm going to draw it like this, and I'm going to say, these are exam 2 scores. Okay, so now looking back at your stem and leaf plot. So page 2. How many F's did you have? How many? 3. 3 F's and 1 D, right? So let's go back to where we were. 3 F's, so I need, in the first thing, 3 F's and 1 D. And then how many C's did I have? 4 C's and then 6 B's and 4 A's. So 4 C's, 6 B's, and 4 A's. Oops. And in those squares, I'm going to do my shading differently. Mine's just going to be squiggly, ugly red. And we're almost done. We need one more piece of a key to show the squiggly, ugly red as exam 1 grades. Exam 1 scores. And then a title that tells us these are first and second exam grades or exam scores. Okay, I will say exam score comparison. That's really what we're doing, is we're comparing. Okay, so a couple things that are sort of on the horizon to be aware of before I stop the video recording. We're almost done with this section. I realize that. We should be able to finish this section and start the next section next time. If you take a look at your syllabus, when I did the schedule, I forgot to include that Good Friday we're not here. So if we can make that up, then we won't end up having to have anything extra assigned. So that's my goal, is to take these 2 sections, which I've allotted 4 days for, and do it in 3, because I think they're short enough that it makes sense to do that. Sound good? Awesome. So no homework, no nothing for that this evening. We will meet again on Monday, and we will look at our last type of chart within this section.